Hello, welcome, and this is another video on delimiters that we use at the time of typesetting using LaTeX. Here we have two outputs given in two boxes. See this output. It's a mathematical expression. In this mathematical expression, you can see this express y is enclosed in a bracket, and that itself is enclosed in another bracket. But the same thing here, the matter is same in the second box also, but you can see difference of this difference in the size of the parenthesis. Okay, in this parenthesis, this bracket, this opening bracket has bigger size than compared to the bracket which is used at the same place in the first box. So how can we produce this change? That is explained in this video. Actually, that use of this bigger size or use of the parenthesis of variable size makes it a very good, very pleasing appearance, very good appearance to this expression. So compared to the previous expression, this is this output is very good. You have to create that, you can see here this is the source code, the part of the source code that actually produces this output. Here you can see x plus y, then cap 2, x plus y cap 2 minus x minus y cap 2, and that creates this x plus y the square minus x minus y square equals slash left. This slash left, slash left parenthesis can be this parenthesis. If you use this slash left left parenthesis, then x plus y, okay, then continued, that expression is continued. You can see that this slash left parenthesis, and then it is closed using that parenthesis is closed using slash right parenthesis. Slash again, once again you can see slash left parenthesis is used, then the matter x plus y and x minus y in bracket, after that slash right parenthesis equal to for x y. Okay, if you copy it and then run the material, or if we take the output after copying it, you can see let's see the output. See, you are getting okay, here a square, that exponentiation effect is not obtained there because of that cap is not correctly typed. Okay, now you can see that expression is obtained there, but you can see that parenthesis, left parenthesis is not well typed in the bigger size. Okay, for that for obtaining that changed output, you can use the use a different source code. You have to change that. You have to make changes in the source code as shown here. So instead of using this source code, you have to use the source code given here. In that source code, you can see slash begin equation star. Then we use x plus y cap 2 and then x minus y cap 2. After that, a slash big L by left parenthesis is used. So see, this is the command used to create that slash big L, slash BIGL. Big L means big left the parenthesis, slash big L bracket, and that after that you can see slash big R the right parenthesis, and again slash big L left parenthesis, and slash big R right parenthesis. So using this source code in the program, you can create the required output. Now you can see, and this bracket, the bracket here, it's a big bracket compared to the inner bracket. So the opening bracket here is a big bracket. Yeah, so you can compare, but all the remaining things, all the remaining matter in both mathematical environment are same. Both in the mathematical expressions, all the remaining matters are same. The difference that you can see is the change in the size of the bracket. Here this opening bracket and the closing bracket, again in the opening and closing brackets, and that size, that effect is produced using that command. Instead of slash left bracket, you are using slash big L left bracket, and then for closing it slash big R right bracket, again slash big L left bracket, and slash big R right bracket. Okay, now see this output in the bracket, which is given in the bracket. How can we produce this kind of summation symbol using subscript and or by giving the left limit and the right limit, etc. in the expression? So here you have to analyze this the output. You have to analyze this mathematical expression should be analyzed thoroughly to write the write the source code. So after that we will then take the output by typing it in the program and by taking and by running the source code. Okay, you can read the source code, the part of the source code. You can go through the part of the source code. So for producing this for n tuple, you have to type a 4. Then n is a mathematical expression. It is treated as a mathematical expression. So n in single bracket, single dollar symbol, it is included. So for n in for after 4 you put you type a dollar and then n, then close the dollar, then hyphen tuples of complex numbers. Then again you have a mathematical expression that you can begin using dollar symbol. In dollar, then we put an ordinary bracket. You can type a symbol bracket, opening bracket. After that you have x, then subscripted. So x underscore 1, x underscore 1, x subscript 1 can be obtained, can be produced using x subscript 1, comma, then x2 can be typed using x subscript 2, comma, then the dots can be produced using slash dotsc dot c command. So slash dot c, there are many commands, different commands to produce the dots, but you can use one or two very that are used most commonly. So slash dot dots c, then comma, x then underscore n, that generates this output xn. Then closing bracket can be given without any additional commands like slash big L, slash big BIGGL, etc. You can use the you can use just that bracket, just the bracket, opening and closing bracket to produce the bracket. Then a dollar symbol is closed, and after that, and in a similar expression is typed to create the similar expression can be, similar mathematical environment can be created by typing the command as given here. After that, you can continue of complex numbers. It is then continued. Then the real the mathematical environment, the centralized mathematical environment can be started using /begin equation command. So this part is this mathematical expression is will be created using this highlighted portion only. So see, okay, then we will now we can analyze that part for understanding the different parts of the source code to generate this mathematical expression. See here /begin equation star. Then to create this to generate this big this parenthesis, this opening parenthesis in big size. In big size, you can use /left you can use the command /left opening parenthesis. This is the command part, /left opening parenthesis, that will create this this bracket, the opening bracket. After that, you have the summation symbol. So that can be that this sigma symbol, the sigma symbol can be created using /sum command. Sigma symbol can be created using /sum command. See that, okay, /sum. After that, after /sum, you have that the lower limit you have to type, k equal to 1, the lower limit you have to type. For that, you can put this underscore. So after sum, you can give that underscore. That underscore specifies that this matter, k equal to 1, the following matter must be typed here. So this sum /sum, then underscore, then k equal to 1. You can after that, since there are 3 letters, k equals and 1, there are 3 symbols. They have to be treated together. These 3 symbols are to be put together in as a single unit, and you should be used here. So for that, you have to put all the 3 in the curly bracket. So in curly bracket, k equal to 1 can be typed in curly bracket, opening curly bracket and closing curly bracket. You can type that. After that, you have that upper limit, and that behaves like a superscript. This is a subscript, and this behaves like a superscript. So to say that it is a superscript, you have to use cap. After that, you can type that matter. If this superscript contains more than one symbol, then you have to put all those symbols together in curly bracket. So that's another important thing. So using that cap, you can type that superscript. After that, you are coming inside that summation symbol. There you have a determinant symbol. So determinant symbol can be given using using a key on the keyboard, which is available on the keyboard. You can see on a particular key there a vertical line is marked. So that key is just above the enter key on the which is available on the keyboard. You can see that it is just above the enter key. Okay, that you can by pressing that key, you can obtain that vertical line wherever you require that vertical line, you can include that vertical line. Then vertical line, after that x, you can see x subscript k, right? Okay, vertical line, then x subscript, so x underscore k, then y, you can type y underscore k, so y underscore k, x underscore k, and y underscore k, and then you have to get one more vertical line, so type that vertical line. After that, you have to close the bracket, you have to give the closing big bracket. So for that, you can use the command /right parenthesis /right, that closing parenthesis, /right, the closing bracket. Then square, the entire expression must be squared. For that, you can use cap 2. After that, you have let the symbol less than or equal to, that you can give by using the command /le. Less than or equal to can be given using the command /le. Then after typing /le, you have a similar expression, so you can repeat it, but you can see some changes are there. So for obtaining this, again you can type, for obtaining this bracket, the expression inside that bracket, you have to write /left bracket left bracket, then for getting the summation, you can type a /sum, then underscore in bracket k equal to 1, then closing that curly bracket. Closing the curly bracket, you can type the cap n, then there are also single letter is that, but you know you can use that in curly bracket also. You can include that in curly bracket also. And then coming inside, we have vertical line. So vertical line, then x you type x, after that underscore x underscore k, then close that vertical line. After that type /right bracket, that will produce this big closing bracket. Then again /left bracket and bracket, then that produces this bracket. Okay, then /sum, after that underscore, then k equal to 1 in curly bracket. Then you have to type that cap n, and then thus you are coming to you are now inside this summation symbol. After that, you can type vertical line, then y, then underscore k, close that, but again once again vertical line. After that, you can use /right and closing parenthesis. Thus by typing up to this /right closing bracket, you have reached here on the end of the mathematical environment. So you can close it /end equation star. You copy it and then paste it to see the output. Yes, you can see here the output obtained, but squaring effect is not there properly. Yeah, because that there here also that upper limits are not coming because of that caps are not well typed there. By replacing that cap by typing the cap, you can obtain the output correctly. Okay, at least at four places this error was there at 4 places. No, okay. You can see here that upper limit here is typed there. upper limit, and then square is available here. Then these two upper limits are typed properly. Okay, see this entire expression. So for obtaining this expression, the source code used, the source code part used is shown here. Okay. And so using this you can understand the use of the command, especially use of slash left then bracket slash right bracket, and that the use of such commands are explained here. Here it is explained here. It is given here that apart from slash big L and slash big R commands, slash big L, slash big R commands, there are slash capital big BIGL, slash capital big L, and then slash capital BIGGL, slash capital BIGGL commands, etc. And there are counterparts. So see, you can replace this L by R to obtain the right the same symbol in the reverted form or in the opposite direction. That's why they are called the counterpart. This L can be replaced by R. The same set of commands can be produced. Similar set of commands can be produced by replacing L by R for obtaining the R count, the right hand side. Facing to the opposite side. So the symbols that are facing in the opposite direction. So whatever symbol you are going to get using the command which ends with L, the same symbol can be produced, which it's in such a way that its direction is just reversed. Or facing in the opposite direction, so that it faces in the opposite direction. The output symbol will be facing in the opposite direction using the command in which L is replaced by R. So which in order produces the delimiters of the increasing size. See, according to our requirement, you can create delimiters using these commands. Actually, if you more bigger and bigger command delimiters can be created using this. But okay, and so these are the examples or uses of various commands to create delimiters of variable size. Okay, then again we have one more example here given, but it is very similar to that given in this box. So you can see that that output you can then you can go through this source code, the part of the source, the lines of the source code, to get an idea about the change or the difference compared to the source code part that we have completed its typing. We have completed the typing of this source code. There you can see the slash left then bracket commands are used, but instead of that you can create the same effect or similar effect you can create by using slash BIGGL command and BIGGR command. Similarly, slash BIGGL then bracket slash BIGGR then bracket, and that is the difference here. Actually, the programmer wants to show you that the difference in the use of. So the effect that they want to produce here is the difference in the use of the commands. You can use different set of commands that are explained here to produce a similar effect. See, so you have to go through the term by term or the symbol by symbol. You have to go through the source code, and then you can understand that. You can try it. So I will show by replacing it. Sorry, by copying and pasting it in the program. Its effect will be explained. The same effect you are going to get. Okay, here inside that you have to change the cap. Okay, okay, now we are going to take the output. Okay, there is no error. We are getting output correctly. So you can see here that matter. This matter is also typed there. Okay, and that running matter is typed. After that, you have obtained that output. Okay, you can just compare these two mathematical expressions. See, most the same kind of outputs are obtained. So I can show that source code part. Source code. This is the source code. You can have a look at this source code. Each part of the source code must be thoroughly analyzed to see the effect of to understand the effect that produces, that part of the source code produces inside in the output. See, when you type this matter, you can treat this this running matter as a complete unit or a complete section of the output. So here 4 n tuple of complex numbers, and these can be treated up to this portion. Up to this point you can treat it as a complete unit. So you can in one step you can complete the typing of that material, but after that you have a mathematical expression, so you have to treat this as the second part of the output, and this is a complete unit. So once you start the typing of that that mathematical expression, you have to continue up to the end of the mathematical expression, and then only you should take the output. So you have to treat this mathematical expression, the entire mathematical expression, as one unit. So typing of the commands that can produce that mathematical environment must be treated as one unit. So you have to when you begin the typing of this begin equation, then you have to continue up to the end of that closing, at the end of that mathematical expression. Up to the command /end equation star. After that, after completing that, you can go to take the output. Okay. Then what next? Okay, then we have a different type of typing next. So we finish it here. We are going to close the video. Okay, thank you.